Welcome back. In this video, we're gonna try to compute the sum of k times n choose k with k going from 0 to n. We're gonna use the Newton's binomial theorem to find this sum here. So here note that since k is going from 0, when k is 0, this sum will be 0, and therefore we can write this sum as k going from 1 to n of k times n choose k, because when k is 0, it's 0. Remember that n choose k can be written as n factorial over n minus k factorial times k factorial. We're going to use this one to get this result here. Now remembering that if we have a and b, two numbers, we have a plus b to the power n with an integer, positive integer. This sum can be written, so this is Newton's binomial, can be written as the sum of k going from 0 to n of n choose k times a to the power k times b to the power n minus k. Okay, we're gonna use this one here to find our sum. Note here that we don't have a and b, therefore we can take a and b here to be 1. So in this sum here, when we write it and when we find a simpler expression for it, we're gonna take a to be b to be 1. That means we have a equals b equals 1. Okay, but first we're gonna write this expression here in this sum here, k going from 1 to n of k and choose k. We're gonna write it in this form because we have an issue with this k. We don't have the k here in the original Newton's binomial. Okay, so one quick way of doing that is that we can write this sum as k times n factorial over n minus k factorial times k factorial. And we can use the fact that n factorial can be written as n times n minus 1 factorial, and k factorial can be written as k times k minus 1 factorial. So this is the key to getting rid of the k here. Okay, let me do it this way. So k is going from 1 to n. So here, n factorial, I'm going to write it as n times n minus 1. And in the bottom, n minus k, I'm going to write it as n minus 1 plus or minus k plus 1. This is the usual trick of adding and subtracting the same number. And we're going to use it here. Okay, so doing so, we have n minus k factorial. It's going to be n minus 1 minus k minus 1. See? This is the same as this one here. So I'm going to have n minus 1 minus k minus 1 factorial. And k factorial, I'm going to use this one here. I'm going to have k times k minus 1 factorial. Now we can move n to the front because it doesn't depend on k. So here n, and this sum k going from 1 to n. I'm gonna get rid of the k. I forgot the k here. I need to have the k here. So now I can get rid of the k here. Okay, it's never 0. So, and I moved n to the front, so I have n minus 1 factorial over n minus 1 minus k minus 1 factorial times k minus 1 factorial. But this is just what's this number here? This one, n minus 1 factorial over n minus 1 minus k minus 1 k minus 1. So this is simply n minus 1 choose k minus 1. Okay, if you don't see it from here, rewrite this one to get back to this one. Now, the binomial theorem starts from 0. So I need to start from 0. To do that, I can either use a change of variable. Okay, so let's call L bk minus 1. So when k is 1, L is 0. When k is n, L is n minus 1. So therefore I have this one, the sum L is going from 0 to n minus 1. Here n minus 1 L. Okay, now I can go back to my k if I want to. I can because k is silent variable. I can write this one as n times k going from 0 to n minus 1 k. Okay, and according to this expression here, let me write close here. So let me write it here. So I have n, the sum k going from 0 to n minus 1. Okay, n minus 1 k. Note here, compare these two. If I have, okay, so this one should be equal to sum a plus b. So I take a equals b equals 1. So I'm going to have 1 plus 1 to what power? It's not n, it's n minus 1. Because this sum here is going from 0 to n minus 1. This one is going from 0 to n. Okay, but I'm going to n minus 1. Therefore, I have this one is I need to have the n here. Okay, so n times 1 plus 1 to the power n minus 1. And therefore, this sum is n times 2 to the power n minus 1. Okay, why I have the n? Because I don't have the n in this expression. The n is coming from here. From here, I move this outside. Okay, and this is the sum that I need. So this one is the sum that I need here. Okay. So therefore, my sum is equal to n 2 to the power n minus 1. And that's what I need. Okay. This is using algebra. We can use probability to prove this one. We can use polynomials. We can use derivatives to prove this result. But this is using algebra and just changing the order and the writing of the expression. Okay, I think that's it for now. If you see any errors or mistakes, please let me know. Enjoy. Thank you very much.